Good afternoon, everyone. Oh, my camera has completely changed. Apologies, everyone. Had it all set up and ready to go. So, good afternoon. My name is Karen, and welcome to the Where the River Meets the Sea video conference for RiverFest 2024. So, we are going to be exploring exactly that. What happens to our water between when it rains, to our rivers, till it eventually heads out to our sea. So we've got someone from Sydney here, we've got New South Wales. If you can also put in your chat there where your closest river is and if you know what catchment you are in. So that'll be a really interesting one to have a look at as well. So I'll let some people put that in the chat while I readjust my screen, because I've got some things I want to show you here today, and I am not sure that they're going to fit in at the moment. Excellent. So we've got some Lawson Public School. We've got someone in the Nepean Warragamba area. We've got North Rocks Public School joining us from Bidjigal Land, and their closest river is Paramatta River. Excellent. So we've got a few groups near Paramatta River, and that's where I was earlier today, along the Paramatta River. And I used to live in the catchment of Paramatta River. So I used to live on the side that went from eastward. Essentially, it was the last hill of the Hills District where things drained into the Paramatta River. I now live up in the Central Coast, and I'm actually right near the coast now. So I'm near Brisbane Waters. So the surrounding hills drain into Brisbane Waters and really directly straight out to the sea from there. Excellent. I'm just moving some things around. Excuse me. There we go. And I've got a little dragonfly there behind me. And this was actually one that was found in my backyard, so in the Paramatta River catchment, and it had come out of a waterway. It was actually a little bit of a pond, and I was lucky to catch it as it just changed from the dragonfly nymph with no wings to developing wings, and this was the moment that I captured it. So we need to also think about the plants and animals that rely on these water sources as well. So let's get started. We're going to explore a lot of different things. I'm going to show you some experiments. Most of these experiments you can do at home as well. And I will be sharing some links with a copy of the recording and that information as well. So very lucky today that we are supported by the Paramatta River Catchment Group to enable us to do these programs. And for those of you that are in the Paramatta River catchment, on Sunday for World Rivers Day, there's going to be an event at Paramatta Park that you can come along to as well. So we're going to start with focusing on water. So does anyone know what water is and what makes it so important? I wonder if anyone can put that in the chat. We need water to survive. Absolutely, we do. That is very true. So all living things need water to survive. We've got H2O. Excellent. So from North Rocks Public School at 5M, H2O is the molecule of water that we'll look at in a minute, because that combination of hydrogen and oxygen, so it's actually two hydrogens and one oxygen, that combination makes H2O, but it makes it very special as well. Okay, let's have a look. I'm just going to share my screen. Oh, some animals live in it. That is really important as well. I like that one, because it's not only the animals that need water to survive, it's the animals that live in it for their habitat as well. So another key component is that water isn't everywhere. So on a day like this, if you're in Sydney, it's been a very, very rainy day, but we had yesterday not so much rain at all. And the majority of our water is actually seawater. So it's salty. So even though 70% of the earth is covered in water, it's not water that's accessible to plants and animals or to us. So our oceans make up 97% of the water on Earth. Now, if anyone's doing our trivia tomorrow, some of the information we talk about today will be quite useful. So of that remaining 3% of water, it is only 1% of that that's accessible. So we've got things that are kept in frozen, in glaciers and ice caps, in groundwater. And then that 1% is in our lakes, inside living things, in clouds, and in the soil. So there's not a lot, and there are many places in the world where water scarcity, which means water not being available, is still a major impact on people's health, and people need to travel long distances to get clean drinking water. So in Australia, we are really lucky. We essentially can turn on our taps. A lot of people have rainwater tanks now as well. So we have quite a lot of accessible access to water. But of course, Australia is also known for a lot of drought periods as well. And that has big impacts not only on agriculture, but on our plants and animals and us as well. So you may have seen this before. You can pop it in the chat if you know what this is called. I'll give you a clue. It's a cycle. And we'll talk about the features of the cycle in a moment. Let's see if anyone's got it. The water cycle, absolutely. We've got a few people there coming up with the water cycle. And we have a lot of these cycles. And there's the rock cycle, there's a carbon cycle, nitrogen cycle, but the water cycle here is really important. And it doesn't always go in this circular motion. So what we've got coming from the surface of our rivers and our ocean and our lakes is evaporation. The heat of the sun evaporates that water, and it turns from liquid water to water vapor, which is a gas, and things that are light like gases go up. So it goes up into the atmosphere. Now, a great example for this is after a thunderstorm, in one of those hot Aussie thunderstorms, and you go outside and have a look at a hard surface like a road, playground, footpath, and if the sun's come back out really quickly, you can actually see the steam coming off that hard surface, because the ground was so hot. When the rain hits, some of it actually evaporates straight away, and that's water vapor. So that's that gas going back up into the atmosphere. So then from there, we've got transpiration that goes from the clouds, and when it starts falling back down again, we've got precipitation. Now, in Australia, most of that is falling as rain, but we do have some places in our alpine areas in New South Wales and Victorian Highlands and in Tasmania that actually falls as snow. So lots of places there, precipitation in cold environments will fall as snow. So snow and rain as it falls back down, and eventually water will all flow downhill. So it's all linked to gravity as well, and it will flow down. Some of it will soak into the soil, and we get it into our groundwater, and then it travels, but it will eventually make its way to the lowest point in the environment, and that environment we call a catchment, and then will flow into our rivers, creeks, rivers, and eventually into our ocean, where any of those surfaces, evaporation through the sun, will go back around again. So it really is lots of different places, and we can get that evaporation from our hard surfaces like our roads and those environments as well. It doesn't just evaporate off the ocean. How long does it take for the water cycle to finish? That's a great question, Lacey. And it's kind of what we would call infinite. At any point, there is water in one place within the water cycle. So at the moment, we have in Sydney, where I am, we've got a lot of precipitation, so a lot of rain coming back down. But yesterday was a really hot, what we would call an overcast day, and there would have been lots of that evaporation happening. So it is constant, quite a constant cycle. And we've also got a little bit of water trivia as well, that water molecules are never actually destroyed. So the water that is around today was once in a dinosaur. It could have once been in an ancient ocean. It's been frozen in a glacier. It's been in a cloud. So it moves around in those different phases. So the solid, frozen as ice, a liquid as running water, and a gas in water vapor. So those molecules of H2O actually always are around. So there's no more or less than there has ever been. So that's why it is so precious. We make sure that our water is as clean and as healthy as possible so we can get maximum access. And when we get a lot of pollution, it means that our water is not as healthy. We're going to look at that in a moment as well. So this is just a quick one of no matter where you are across Australia, you can have a think about your catchment. So catchments can be really quite big, but they can be small. So you can actually make a catchment. If you are holding your hands like this and let water fall in, you're actually making a catchment. You're catching that water, and any water on the other side of your hand will actually be in the next catchment, but you're making one here. So you can actually use clay or sand to actually make different shaped catchments and use water to move through to see which way it's going to go. But in Australia, we have these big catchments, and the largest one on the east coast is the Murray-Darling Basin, and that's linked to the Murray River and the Darling River, and it goes all the way up from sort of central Queensland, everything west of the Great Dividing Range, all the way down to Adelaide, where the Murray reaches the Southern Ocean. And within that, we can see lots of smaller rivers and catchments as well. So all of those different catchments are the joins of rivers. So the highest point, and then they flow down to the rivers on either side. So it's a really great way to have a look and think about where your catchment is in relation to this. How long can a dingo survive without water? It's one of those really hard questions with a lot of different animals. A lot of animals have different strategies to survive in low amounts of water. I'll just unshare for a moment there, because we're going to look at one of our properties of water. So animals can survive in lots of different ways. We have some frogs that will burrow and hide underground until the rains come. Most animals that will drink water need it fairly regularly. So it's a kind of thing that you can go far longer without food than you can without water. So it is a really a difficult question to answer, but usually it's only days that most animals can go without water, especially sort of the mammal kinds of animals. So I want to quickly talk about another awesome property of water. And I'm going to try to demonstrate it here without making a mess. And of course, water experiments with a computer can be a little bit challenging. So I'm going to make sure, or try to make sure, that I don't actually drop any in my computer. So what I've got here is just some water here, okay, in a container. And if I had a nice flat tray and a bit of a surface, I would try to do a different demonstration, which is trying to float things on water. So if you've ever done it before and filled up your glass really, really, really super high, and you look at it sideways, you might notice there's a little mound on top of the water. And that's because water loves to stick to itself. So it creates this extra barrier that means that it can sit slightly higher than the sides of the container or the glass. So if you do that at home, letting sure an adult knows, you can often float a paper clip or a pin on top of that water, because the surface tension, or how much those water molecules like each other, stop it sinking. Now, usually when I do this on camera, it doesn't work, because I wash my containers all the time. So there's always a little bit of detergent in my containers, and that impacts the surface tension. But we also have, now excuse me, I left it out of my reach. Ready? Here we go. Got it. I'm going to use some cinnamon. Now, cinnamon is a substance that, well, smells really good, but it doesn't like water. So it's something that we call hydrophobic. So I'm going to see if I can actually do it on camera and try not to get cinnamon in my computer at the same time. So let's see. Oh, I'll move my hand a bit lower so you can see what I'm doing. Oh, what are the chances this will end up in my... So as I'm sprinkling it on, it's not really sinking. So it's actually making a layer. Yes, so we've got someone here mentioning it doesn't sink. So hopefully when I put my finger in, you'll see that it kind of looks a bit shiny. And it looks brown because it is actually coated with the cinnamon. So the cinnamon is stuck to my finger. I should have shaken that more first because I've just dropped a whole lot of cinnamon in my keyboard. But the cinnamon protects my hand. So if I hold it up, you can see a little layer of cinnamon, but I'm not wet. So instead, the cinnamon has covered my finger and blocked that layer. Now, we've got someone saying it's a little bit like oil, and it absolutely is, and that's going to be the next demonstration we have a look at as well, because some things do not like to mix. Are you going to have to wash your hands? No, I've just wiped it. But what I'm going to do now is put a bit of detergent in here. Let's see, I did put a lot of cinnamon in. So it is really cool. We can still see it. It still hasn't mixed. Now, I'll try to give it a little mix with my skewer. And it's kind of got little bits dropping down, but not really. It's kind of stayed quite separate. So let's see if I put my detergent in. I could just make a beautiful smelling mess. But, oh, there we go. Can you see it happening already? As soon as that detergent goes in, it starts dropping. So we can already see it's gone murkier. And if I start stirring it now, it's dropping out of that protection. So the detergent breaks that surface tension and it allows it to mix. So it is quite quick how the detergent has that impact. And luckily, when we use things like this, detergent and the cinnamon actually smells really nice. So detergent does this on purpose. Wow, you can't even see through it anymore. Completely mixed. And the properties of detergent are to do that specifically. They want the detergent to break down the oils and fats. So when you're washing your dishes, it actually helps come off and it doesn't just cause a layer. So it's on purpose. But imagine if all of these detergents get into our water. So I'll just have a look, show you the next slide. Oh, we just got a question there. What type of animal species can survive the longest without water? Ooh, mammals, reptiles, insects, or birds? In general, I think it's probably the reptiles, because the reptiles can slow their body down to allow them to not have to drink very often. Okay, so I'll just go back to my share screen so we can look at that surface tension. So it's all about the molecules at the bottom there. So the atoms, the individual atoms of the hydrogen and oxygen bond together in a really specific way, that H2O, that then they want to attract to each other. Another good example to do is with a water dropper and actually have a relatively flat plate. You could even do it with slightly different colors. And if you put them close enough to each other, they will eventually join and make a bigger drop because they're attracted to each other. So this works really well of how we can float needles and paper clips on water, but in the real world, it is mostly for these kinds of animals here. A lot of our freshwater invertebrates walk on the surface of the water. So we can see this animal here is called a water strider, 6 long legs, and that is really important. A big, heavy, round thing will drop straight through that surface tension. But if it's a light animal and it spreads its legs out like that, it spreads its weight. And it means each leg is not having a big impact on the water and it can essentially walk across that water. So it's an amazing way to do it. Lots of different animals do. They use that surface tension to stop themselves falling through the water. And there's some really cool animal techniques for them to break that surface tension. There's some animals that will like spurt things out to make a ripple and for them to drop down. Again, this is a fun activity you can do with some water, some aluminium foil, and you can actually make and cut out some sort of insect shapes and have them floating on the water. You can even just blow or use a straw to blow them across that surface tension. So something that is light, that spreads the load, is great. Another way that you can look at some of this is some of the boat experiments as well, that you can get that hull that spreads the water aside, that allows the boat to essentially not sink, because it moves, disperses water, moves it out of the way to allow it to stay. So with these properties of water, we've already mentioned oil, but we have these impacts on our environment. So oil has a direct and indirect impact on our both freshwater and marine environments. So we've got oil in air pollution, we've got runoff. Often when it's been raining and you look around car parks and drains, you can often see that sort of shiny rainbow of oil. There is natural seepage of oil that happens when where some of the oil is coming from, but also the extraction of oil as well has an impact when it leaks, and transportation and accidents. So these oils are ending up in our marine environments, and they're sitting on the surface of the water and not mixing. We can see it here. This is an oil spill into a river, and we can actually see that there. Now, the impact on birds' feathers is huge. They can't get that oil out. It stops their ability to fly. Animals that are under the water can't come up to the surface to breathe. And even animals, if it gets further down in that water column, can have a big impact on them as well. So let's have a little look about how that's happening. So I'm going to do two things first, because there's one that we need to have a look at about what we put down our drains. Okay, so that's what we're going to start with here. Now, I'm letting you know this is food colouring, but it is to demonstrate our toilet. So what we're going to put in is toilet paper. And I'm going to rip it up into a slightly smaller piece to make it about the same size as the piece. One square of toilet paper is one small square of paper towel. Okay, so we're putting that in our water, and we're going to come back to it at the end. Okay, I'm just going to let you know it's only water and these things first. I'm going to give it a little stir. Okay, they're all mixed up together at the moment, and we'll come back to that at the end. So what I've got in my blue water is just water. Okay, I'm going to put my little bit of paper towel under me because I don't want to make a mess. And I'm going to pour in some oil. So it doesn't take long for it to separate. And yet, Sid, it rises to the surface. So we can see that clear distinction of between oil and water. So imagining a bird that dives down to catch fish and goes through an oil layer. It means that they can't regulate their heat. They can't get the oil out of their wings, but anything underneath has this barrier that it needs to get to. So all of these oils in our environment, is that the rest there? That was the rest of my oil. I knew it had been leaking in my, my water box, so I was quite happy to use the end of it for this. And again, quite a good experiment. If you do this one at home, do not use really expensive oil. Just use a little bit of cheap vegetable oil. This one here, you don't need to use quite as much as I did, but I wanted to make sure it came up on camera really well. And when you want to dispose of this, maybe into the garden, okay? You don't want to put this down the sink or in your waterways. So, because we don't want to add more oil and water to the environment. So what do you think will happen? How do you think I can break this down now? Separate those two layers and mix it Any ideas? With the soap again, with the dishwashing soap. So let's try that. I'm going to put my cinnamon back over here. And we can just see how it still hasn't separated back out, has it? It's mixed and it's stayed mixed. Yep, we're going to put the soap back in. I just need to get myself a stirrer. I try to use new stirrers all the time because otherwise they've already got detergent on them. So let's see if it's as obvious as before. You can actually see it sinking between the oil and dropping down. Oh, can you see the bubble there? So that's the detergent bubble between the oil and the water. So it hasn't made it through, but if I start stirring it, we can see that that oil mixes. Okay, it is sort of separating back out into sort of a bit of a bubbly layer. So it's like the detergent has mixed with the oil as we expect. And then we've got our water at the bottom. But as we keep stirring, we can see how easy it is to mix that up. So it is really important that we think about not only the water, things like the oil, but everything else that goes into our waterways. So what else do we think washes into our waterways? From the rain or the wind? You can pop it in the chat. Rubbish, yes. Pollution, dirt, bacteria, rubbish. Fabulous answers. Eroded soil, yes, we get lots of erosion and runoff. Exactly. Awesome. So all of these have impacts into our waterways. So we can't just look at one thing, but there's lots of different ways that we can make some changes and make a difference as well. Just going to have a look at our paper towels. So here we go. We've got our paper towel and our toilet paper. So which one do you think's just fallen apart? The toilet paper, yeah. So if I actually take out the paper towel, oh, it's stuck on my skewer. I'll have to put it down now. So do not want to drop it all over me. So I'm giving that a little squeeze. And our paper towel was only a small piece, but essentially I can open it up. If I do a really big one, I can rip it, but it stayed what we would say is intact. So it didn't break down enough. So toilet paper is designed to really be a single use. So it gets used, it goes down the toilet and it breaks down. So that's really important. And yeah, so since it is thicker, it is more absorbent. Absolutely. So paper towel is designed to not break apart immediately when it comes in contact with water, because we don't want that to happen. We actually want it to last. And, you know, if you want to be very sustainable and you've got paper towel that has just had water on it, you can actually hang them out to dry and pretty much reuse them until they get sort of more dirty. So if there's lots of food waste on it, you don't want to keep them, but they certainly can sort of be reused for just water purposes. So let's have a little look at what happens next. So this slide that's coming up in a moment, so this is actually a creek. It's a park actually called Cows Lane, and this is a creek that runs through pretty much down to Paramatta River. So what's happened here? There's been a lot of runoff. So a lot of rain from all the surrounding suburbs, and lots of material has ended up in here. Now, they have actually since removed this particular bridge because it kept getting jammed like this. So this is what we would call a log jam. Logs and pretty much whole trees got stuck in there, branches and leaves, they get washed up and tangled and stuck, and it can actually dam the river or the creek. But if we look in here, can see some plastic bottles in there as well that have all washed down, as well as this other debris. So 80% of our litter in our waterways is made up of plastic, including plastic bags, bottles and food wrappers. Now, I have to say, I have seen such a great improvement since Return and Earn has come in. I used to work at Sydney Olympic Park, so we would often see a lot of material washed into our wetlands from wind and rain, especially after big events. But because there's a value to that now, we find that there is less of that material being washed in. So some of those programs can be a fabulous improvement. Now, this one here, this is someone mentioned eroded soil. This is actually up at the Central Coast, and this is after the 2019 bushfires. So what had happened after there was a lot of essentially clearing, a lot of the surface was free of vegetation. So after the next big rains, lots of sediment washed into the water as well. And we can see that here, all of that sediment washing out into the ocean. And that can have an impact, even though it's from a natural source, it still has an impact on our environment. To help, we can refuse stuff and pick up litter. Absolutely. This is exactly what I want to hear, is how we can make a difference. So let me just see what our next slide is. We've got a couple of ones there thinking of multiple impacts in our coral reef environments. That sediment can be an impact, runoff from farms as well. I'm just going to skip through, but this is a really positive idea. So we've got these green filters or a grey funnel. So when we have beautiful green spaces, the roots of the plant help protect the soil, and it means that we can get rain soak into the soil and become groundwater, and it holds it for longer. But if we've got lots of hard surfaces like roads and gutters, then we have the water move really quickly. And when water moves quickly, we can get things like flash floods and those kinds of things. So thinking about creating more green spaces, slowing water down can be a really great way that rubbish and pollution can get captured in the environment and doesn't directly end up in our waterways. So very good to have these slow filters. So planting rain gardens, changing some of our way that drainage is, having lots of gardens and tree roots protecting our soil as well. So there are other options that are big picture things that councils can do, putting barriers to stop the rubbish getting directly into the water. But I want to hear from you. What are some of the other ways that we can think about how to protect our environment? So we've got, Lacey's also suggesting planting new trees. Absolutely. So there are lots of areas that we can do that. There are ways that we can make sort of almost like swamps and wetlands that slow the water down and it gets caught for the environment instead of going directly out to the ocean. We've got no littering. That's an excellent one. Oh, installing rainwater tanks, a wonderful one for Australia, that we either get too much rain or not enough or not the right rain at the right time. So rainwater tanks are a great way to be able to capture the rain when there's a lot of it, and then we can use it in those times that we don't have as much during droughts. Collecting rubbish, installing more bins, use less plastic. I'm loving all of your ideas. And I do find that a lot of our school and students are already thinking a lot about this already. So we can reuse, recycle, and reduce. So reduce the amount of packaging that we get in the first place, reusing where we can. So a lot of the things that I use over and over and over. And sometimes I will use them for different things. I had a big milk container and I had a nice big handle. So I actually cut it off and made it into a scoop that I could use for my chicken food, and I actually used in the garden. So there's lots of different ways that we can think about that as well. I'm loving this one here. Think about something before you pour it down the drain. I have been starting to have a jar by my sink. And so what I can do is, if I've got oil or fats, I can pour it into that jar. When that jar's full, I can put the lid back on and put it in my normal waste bin. We can't really recycle it anymore because it's got, you know, lots of food waste in it, but it's not going down my drain. And has anyone heard what happens in the drains? It's got a really interesting name when there's too much oil and fats and it blocks up the drains. Does anyone, maybe some of your parents might have, or teachers may have heard what this one's called? It's quite a funny term. Let's see. So it's called a fatberg. Disgusting, isn't it? So a fatberg, and it happens in a lot of our drains after many years of people putting too much fats and oils, that it gets clogged up. It's also getting clogged up with wipes. So lots of people using disposable wipes, which they say are flushable, but they're not really, because they're strong like paper towel and they don't break down like our toilet paper does. So that mixes. So things that shouldn't be down the drain mixes with the fats and oils, and it creates a blockage called a fatberg. And yeah, I think there's a great documentary of one in London that was like tons and tons of material that was stuck down there. So we've got some more wonderful ideas here. Drying out wet paper towel to use it again. Simple as that. Sending boats out to pick up rubbish in the ocean. And opening an ocean animal hospital. Well, luckily we've got some wonderful wildlife carers. Places like Taronga Zoo absolutely take rescued wildlife that have either been in oil spills or have got tangled in plastic or swallow plastic, and they will absolutely do that. They will help these animals stay nice and healthy before releasing them back out into the wild again. And there are some really cool things. There's one really awesome rubbish collection that they've got at the moment, which is called a sea bin, and I'll send that in my follow-up. National Maritime Museum have been working with sea bins, and they've got them near there. So there's kind of like a bin that sits in the water, and the water kind of just tips over the edge. So any plastic that's in it falls in, the rest of the water can go back out again, but it collects the rubbish. And it's really good because it's what we call passive. No one has to actively do it except when they empty that big bin out. So it's a great way to sort of look after and protect that rubbish. And there are lots of people doing great research on how to get rid of the Great Pacific Garbage Patch, which is due to ocean currents. They've all kind of washed in together. There's also great communities doing work on what's called ghost nets. So ghost nets are old fishing nets and fishing material that has been lost out to sea. And because a lot of them are plastic based, they float. And a lot of the traditional owners in Northern Territory, Queensland, the Tiwi Islands will actually weave these ghost nets into beautiful marine animals to really demonstrate the hazard of that material there, but also the beauty of the wildlife. So I'll send you some pictures of some ghost nets. They are absolutely amazing. Spreading awareness about the dangers and risks and how to reduce the damage. And the fact that you'll come along to this video conference today is about exactly that. It's about learning, sharing information with each other. I'm loving all of your great tips of how to protect and help our environment. Every little thing that we do makes a difference. And I'm a big fan of, even if I didn't drop that rubbish, it doesn't mean I don't have to pick it up. So we can pick up rubbish next time if you're at school or at your local park. Have a look. Are there grates on the drains that might stop rubbish and plastic pollution getting into the stormwater drains? Is there barriers to stop material going off into the gutters or the rivers? Is there vegetation on the sides of your creek and rivers? All of these different kinds of things can make a bit of a difference. Maybe your school wants to do a bit of, or local environment wants to do a bit of tree planting to protect the edges of those local waterways. You could even just go out and do what's called a bio blitz and spend some time looking and listening for the animals that are around. Are there frogs nearby? Are there birds? What animals are using those habitats? And what would those animals need to have a better life? Do we need to plant more little plants? Does there need to be a frog pond? At my house, I've recently built a dragonfly garden because I had lots of mosquitoes, and I know dragonflies love mosquitoes. So I thought that would be a great way to reduce the amount of mosquitoes and create this habitat for some of those freshwater animals. So Lacey had some great ideas. Well, a question: how can we convince people to stop littering and start helping wildlife? Oh, Lacey, that is a question that has been going on for a long time, and sometimes we can't convince people. We can't do it. But if we do things ourselves and we create communities of people that do want to make a difference, that's the best place you can start. You might not be able to convince someone to change their ideas, but if they might see you doing something really positive and maybe want to do the same thing. So yeah, lead by example. And it sounds like with the wonderful ideas you've all had that you're doing that already. Riley's suggesting so to donate as well. Yeah, so you can donate time by being part of a cleanup Australia Day or a school cleanup or a community one. You can join, there's land care and bush care groups. You can volunteer. There are lots of ways that you can help the local community. If you can start a community action as well. So with your families or with your schools, you can say, we're going to do this planting, or we're going to spend this month, and September is also Biodiversity Month. World Water Day was last Saturday, and World Rivers Day is next Saturday. So lots of different dates to be able to think about getting involved in. Lacey's also suggesting we can have a Save Our Wildlife Day in Australia. Absolutely. All of those things are really positive ideas that you can do as an individual, as a community, and the more people that get involved, the more difference that you can make. Lacey's also saying platypus especially need our help. The platypus is quite an endangered animal because of their habitat. Freshwater environments, they used to be found throughout Sydney, and they're really only found on the outskirts. Now, I have never seen a platypus in the wild. I have been looking, and they are really in need of that protection. So protecting where they're nesting as well, so they can get caught in yabby traps and those kinds of things as well. But also, it's just that understanding how we can learn more about them, to learn what our wildlife needs. So I think all of the things that you've suggested are great. Looking at habitat, reducing the amount of litter and pollution, and thinking about what goes down our drains. And there's no reason, if mum and dad have bought something that you think, oh, that's not good for us, can we reuse it in a different way? Or no, don't squeeze the tuna tin down the sink, let's put it in a jar. Those little things make a big difference over time. And you're the generation that is going to make the biggest difference. So thank you so much for joining me today and having so many wonderful ideas about what you can do to help our environment. So are there any final questions before we wrap up for today? Oh, one time 11 platypuses were found in a trap. Oh, well, that is very, very sad. So that is one of the things that we do need to think about. things that we're not intentionally or not doing on purpose. Now, I'm sure they didn't want to collect platypus. That's not what they were trying to do, but accidentally, by having a yabby trap or something out, the platypus have got tangled. And also those things that are left behind, like those ghost nets. When things get left behind and aren't even being used for their original purpose, the animals can get caught. So we call that bycatch as well. So that can be very, very sad. Well, thank you everyone for joining me today. A big thank you again to Paramatta River Catchment Group for supporting this program today. And remember, get outside, learn more about your catchment, your local creek and river, and yeah, anything you can do will make a difference to the environment. So thank you all very, very much. And I look forward to seeing you again soon. And if you haven't registered, join us for the trivia tomorrow. Some of the information we talked about today will be in it. So you're one step ahead. So I'll send a link when I send off the recording to that as well. So thank you all very much and goodbye.